In this video, we're going to talk about solving absolute value inequalities. And what this is combining the previous two sections that we did into one complete concept. So what I want to do is practically think about what values would work in this. For example, if I took the absolute value of 5, that would still be greater than 4, so 5's up here. If I took the absolute value of 6, that would still work, and that's up there. But let's think about other values that would work in the negative. If I took the absolute value of -5, so taking the absolute value of -5, well, that's the absolute value of -5 is 5, so it's 4, so that does work. It's back here, so I'm going to put this value at -4 here. So -5 would work, -6 would work. That's also, once I take the absolute value, that's greater than 4. So I could also do 7. I could also do -7. Taking the absolute value of both would both be greater than 4 once I did this. And if you notice, everything that I'm doing is greater than is going on the outside of my two boundaries set up by the absolute value of 4, which is 4 and -4. And if we look, that greater than kind of relates to what looks like that or situation or that union situation. So when I want values where the absolute value is greater than a value, it's going to be outside those two boundaries. So let's look at the idea of less than. So if I think of things that are less than -6, so the absolute value of 5 is definitely less than 6. The absolute value of 4 is definitely less than 6. But if I go the absolute value, let's say -10. Well, the absolute value of -10 is going to be 10, and that is definitely not less than 6, so that doesn't work. So I can't just extend it all the way down that line. That doesn't work. So let's think of some other ideas, kind of set up similar to what we did with the 4 and -4. So I'm going to do 6 and -6. So -10 didn't work, but 0 definitely will work, so that's in there. But if I take the absolute value of -4, absolute value of -4 is 4, that's less than 6. So is -5, so is -3, so is 2. And so you're looking at all these values. And I know I'm speaking kind of quickly, but you can test any of these. Absolute value of -4, is that less than 6? Well, the absolute value of -4 is 4. Less than 6? Yep, that works out perfectly. So all of these, what happens is now, is they're all in between this 6 and -6. And that looks a lot like my AND situation, which is typically the intersection. Or it's my AND intersection, and it's the same as the, it's inside. There we go. That's the one word I didn't include. Now again, I have here, so these are not equal to, so we're going to have the rounded brackets here, we're going to have the rounded brackets here, and here, and here. But what is universal is that when we have a absolute value less than a situation, it is going to be, actually let's write it similar to what we have here, greater than. This is always going to be an or union situation. When we have x is the absolute value of whatever it is less than the situation, this is going to be an and or an intersection. So let's apply those principles to a couple of example problems. Okay, so scrolling down a little bit, we have these problems, and I want to emphasize that we're still going to isolate the absolute value. But the one thing I want to identify is that this first situation is a less than, so it's the same thing as this one. So whatever I do, I am going to have the and or the intersection. This one is greater than, so I know I'm going to lend myself to the or. So let's start to solve this. This one here, this is completely isolated, so just like with our absolute values, we're going to have both with the 16 and -16. But if you notice, I didn't write the inequality in there, and I'm going to talk about that. So when we had the and situation, if I noticed, it was less than the positive and greater than the negative. Or the way I like to think about it is we write this inequality exactly the way it looks. It's a little sloppy. Apologize, my handwriting isn't great on this unit. And then we write with the sign switched and the sign switched here. And that's still going to give me that situation where I'm less than the positive and greater than the negative. So I'm going to pause the video and I'm going to solve both of these inequalities. So I've worked down and solved both of these inequalities, and the big thing is you have to put either the and or the or in this situation. And like I said, when it is less than, we are going to have and. So that's one of the things that's missing a lot when I see this on the test. We solved both, we set them equal, we set the inequalities both with the negative and the positive, but we have to do the and, which means we have to do the graphing. So we've graphed both of these situations, and the one thing we have to do is give the solution set. So again, remember the and is the intersection or the union, or excuse me, the intersection or the overlap between both of them. So we have negative 21 over 2 going to 11 halves, and they both need to have the squared off brackets. So let's look at this next one. Again, we're going to isolate. I can't do anything. Oops, we're not going to subtract. We're going to subtract that 7. And then so we got 3x minus 7 is greater than or equal to 3, and then we got to divide by 3. I got to do all this work. I don't care about the intersection or union until I get that isolated. Now I have a place to go. So again, remember, because it's greater than, it's going to be or it's going to be on the outside. But we have to solve it. So I'm going to go x minus 7, writing the inequality exactly the way it looks. And then I'm going to write x minus 7, flipping the sign, and changing the sign. So solving this one, I've got x is greater than 8. Solving this one, I've got x is less than 6. So again, putting both of these values on, and we're going to again highlight. So we have this going less than 6, and I'll put the markers on there in just a second. And then this one is going to be greater than 8, and it's an or situation. So as we do this, we have 6, and it's going to be a hard bracket. This is 8, and it's also going to be a hard bracket. So when we have two intervals that don't overlap, we have to indicate both. So we have negative infinity going up to 6, and we have 8 going up to infinity, and it's the union between them both. Now this next one here is a little bit tricky, because we're just trained that when we see an absolute value and we have a negative on the other side, that we want to just say, oh, there's no solution. But this is an inequality. So I'm wondering what values, remember all of these are positive. This absolute value is always positive. But I'm not asking when it's equal to negative 25. I'm asking what numbers make it greater than 25. Greater than negative 25, excuse me. And in this case, it's all of them. Or from negative infinity to positive infinity. Because think about it, no matter what I put in for x, negative, positive, anything, once I take the absolute value, it will be positive, which will be greater than negative 25. So sometimes it's a little tricky that we need to make sure we pay attention to exactly what they're asking. So the negative being set greater than or less than to a negative number is the one that kind of warned me to kind of slow down a little bit and check this out a little bit more. So let's look at this one. I'm going to add 12 to both sides, and I want you to think about it. As I set this up, will you have an and situation or an or situation? And hopefully you said and, because it's less than. Any situation where I have and. So I'm going to have, again, writing the inequality exactly the way it is. And I'm going to try to make it down here. So I have 4 minus x, and then switching the sign and switching the sign. So I'm going to subtract 4 from both. So we have negative x. I've got a negative, so that, remember, that means that I've got to do something else with my inequality. So I have 18, dividing both sides by a negative 1. So I'm going to get positive x. I'm going to get negative 18, but I have to switch the sign. Because again, I had to divide by a negative 1 to get that x to be positive. And it's going to happen down here too. So minus 4, so I've got x. Negative x is greater than negative 26. So then I'm going to have to take and divide both by a negative 1. So I've got to switch the sign when I divide both sides by the negative. And then you want to graph it. Remember that it is, because it is a less than, it is and. I want the intersection of them both. Because I wanted the and situation, what I'm going to do now is I'm going to just say I want the overlap. So the answer is from negative 18 going up to 26.